Good evening, students. This is Deekam Pathak from Freebirds Experiences. I welcome you all to this wonderful series called Fun with NCERT. And today's session will be taken by Mr. Rupesh Mandal. So without any further ado, let's start with the session. Mr. Rupesh, please continue on with the session. Thank you.
Thank you, Deekam, for giving me this opportunity. Once again, I'm here for starting with a new session of Fun with NCERT. So I would like to thank Innovation Hub, Shillong Science Center, and Freebirds for organizing this kind of session for the students. So in this session, we are actually trying to learn certain basic concepts about like physics, chemistry, or those kind of things, basically science, through some activity learning. So let's get started with this. So in today's topic, we will be going through this particular thing, that is work and energy. So let me introduce myself. I am Rupesh Mandal. I am working as an assistant professor in the Department of Computer Science and Engineering in Assam Don Bosco University, Guwahati. So as we said, in today's topic, we will be learning about work and energy. So before going into the definition of work and energy, like we all know, like generally how we can define work or in day-to-day activity or day-to-day life. Okay, so how we can define work? Work can be defined as any activity involving mental or physical effort done in order to achieve a purpose. Fine. So it is an activity involving that can be involved with mental or any physical effort done in order to achieve any purpose. So what can we say? Like if I'm reading, so I can say I'm actually putting some effort. Fine. So after reading, so we may get some knowledge. So while reading, we are actually releasing or we are utilizing our energy to read. And definitely it is happening that once we are reading for a long time, we often get tired. So that means we are putting effort. Okay. So those kind of activities which involve in any sort of mental or physical effort done in order to achieve a purpose can be defined as work. Okay. And the energy. So what is energy? Normal definition we can say it is the strength required to do sustained work. Fine. So it is basically the strength. So who can work? Those who are having strength. So it is the ability or we can say the strength required to do some sustained work. Okay. So these are the very basic definition, or we can say we are using this word of like work and energy in our day-to-day concept. Okay. So in this, I have given some figure. So in one of the figure, one boy is actually reading. So he is holding some book and he's actually reading and enjoying. Or he may be reading one particular subject or any particular chapter. Okay. So if a student is reading, so definitely he is putting some effort, isn't it? So if the student is reading, he is putting some effort and he is losing energy. And eventually, after some time, that particular student will get tired. And after reading, what will happen? The student will acquire some knowledge out of it, like from the reading. So we can say the student has done some work. Or in more specific way, if we say the student who are actually doing hard working. Okay, the student who are actually doing some hard work, they will be getting more or they will be getting good result. So if the student is putting more mental stress, more stress in reading, so they will get good grades. Okay, so that we can say those students are putting a lot of effort. So they are actually utilizing their energy in reading. Okay, so in that way we can understand. The second picture signifies that a boy is actually doing the skipping. So while skipping, he is actually putting some effort. Okay, that boy is actually jumping, he is rotating his arm or that in the action of skipping. So he is putting a lot of effort in doing that as well. In the third picture, a small kid is actually riding the bicycle. So while riding the bicycle, he is actually putting effort in the pedal, and because of that mechanism, So like while he is actually putting effort in the pedal, the bicycle is actually moving forward. Okay, so this boy also, or this kid is also putting some effort, and he is actually achieving some purpose, that he is going forward. Fine. So here also the kid is actually doing some work. Until what time he can do, that particular kid can do the work? That till the point, till he has like good amount of energy. If he is tired, so in that sense we can say he doesn't have enough energy to do. Fine. Similarly, the last one, a man is pushing some like objects using some trolleys. Fine. Using some forklift, he's pushing some objects. So if the objects are very heavy, he need to put a lot of pressure, or he need to put a lot of force to push those items. So here also the person who is actually like pushing those items, he is also doing like some amount of work. Okay. So I hope this particular concept is clear. The basic definition, or the day-to-day, like I mean to say, the very general definition of work and energy. Now, when this definition of work and energy we understood, once we are going to the like scientific definition, there will be some sort of contradiction. What sort of contradiction may be there? Let's see. So in general definition, we have seen that work is basically activity of involving mental or physical effort. Okay, but in scientific definition, what is work? Work is said to be done. Work is said to be done when a force acts on an object and the object is displaced in the direction of force. Okay, so what is the most important parameter in the scientific definition? That some amount of force need to be applied on the object and the object need to be displaced from its position. What is the meaning of displacement? That the object need to move from the position. Okay, then only we can say that work has been done. Once again, I am repeating this scientific definition. The work is said to be done when a force acts on an object. That means any sort of like any object, if it is there and any force is acting on that particular object, and because of that particular force, the object is actually getting displaced, or in other words, we can say the object is actually getting moved from that particular position where it was already where it was previously placed. So if like some sort of movement happened or some sort of displacement happened in the direction of the force, then we can say the work has been done. Okay, now there is a formula for calculating the work. The formula is like for W, that is work done on an object is the product of force applied and the displacement. So we know how much amount of force that has been like applied on any particular object, and if we can calculate the displacement, the distance that particular object has moved, that is called the displacement. Okay, like 2 centimeter, 5 centimeter, or 7 centimeter, the distance that the object has covered by the implementation of, or by the application of some amount of force. So we can calculate the amount of work done. So the formula is W is equal to F into S. And the unit of work done is joule. And it's like it can be represented with capital J. Okay. So let me give you one very like small demonstration like how like the work can be done. So for that, I will stop sharing this and I will switch on my camera. Okay, let me change the camera angle. Okay, we will be doing with this only. So let's suppose I have a ball over here. Okay, so if the ball is like placed in one particular location, okay, so if the ball is not at all moving from where exactly it is placed, then we can say there is no work done, or we can say the work done is 0. Okay, But when we apply some this, okay, I don't know how much amount of force I have applied because I don't have that measurement like or measurement device with me. I'm just putting some sort of force like this. So when I'm putting this amount of force to one particular object and the object start moving, okay, suppose I'm just applying a very little bit of force, so it is moving like that. Okay, so it has gone to a very little distance and we can calculate the distance till how much distance it has actually moved. Okay, so if we know the amount of force applied and if we can measure the distance, we can easily calculate the amount of work done. I think you people might have get this one. Like, it is very simple. We need to know how much force we are applying. We need to calculate the displacement, the distance covered by that particular object by the application of that particular force. And through that, we can easily calculate the work done on that particular object. Okay, so I will present my window once again. Okay, so this is how we can calculate work. So now, if you consider the previous slide where I was discussing the general activity, like general definition of work. So in the general definition, we have also considered that reading is kind of a work, and we consider reading is a work. Okay, like I am by profession, I am a teacher. So if before I teach student, I need to read. Okay, before I make these slides or before I'm giving this lecture, I had to read. Okay, so when I'm reading, I'm actually doing some work. Okay, but that is in general definition. But if I'm calculating or if I'm trying to understand the concept of work, like scientifically, I am not at all doing any work, because while I am reading, okay, I am not doing any sort of displacement or I'm not moving that particular object. So simply that boy is actually holding the book, but that book is not at all moving, or he is not actually displacing the book. So if the boy, suppose if the boy is not reading and he is just keeping the book aside or he is just placing the book somewhere, then we can say, okay, that boy has done some amount of work. But in scientific term, reading, just reading the book or like putting some sort of mental effort, category of work. Okay, so that is how the general definition is actually getting in contradiction with the scientific definition. Okay, and as we are, like, you people are science students, so you need to go through, like, you need to have that scientific knowledge, scientific definition with you as well. Okay, let's take the example of this second picture. In the second picture, the boy is skipping. So when he is skipping, he is actually like doing some sort of displacement, that is, he is actually moving his feet up and down. So while he is doing all those activity, he is actually doing some sort of displacement. Fine. So there he is doing some sort of displacement. Actually putting some effort in the pedal, and because of that pedal, the cycle is actually moving forward. So cycle is actually getting displaced. So it is also falling under your scientific definition. And the last one is putting some effort to move that object. That objects are moving, and we can say the objects are getting displaced. So that's why we can say it will be falling under the scientific definition. The only thing that is not actually falling is reading of book. I hope this one is clear. Fine. Okay, so let's move to the next one. So when we say work done by a force, okay, so there can be two or basically three categories that we can divide the work. So these three categories are positive work, negative work, and zero work. Okay, so let's see what exactly are these positive, negative, and zero work. So the work done by a force is positive if the force and the displacement are in the same direction. So when we say, when we are applying some sort of force and that particular object is also getting displaced in the same direction in which we have applied the force. In that case, we can say it is a positive work done. Okay. The next one, negative work done. When we are saying the work done by a force is negative if the force and the displacement are in opposite direction. So whenever we are applying any sort of force to any particular object and the object is actually getting displaced in the opposite direction, that is a kind of negative work done. Okay. And the last one, that is the work done by a force is zero if there is no displacement at all. So we are putting some effort, but ultimately there is no displacement at all. Sometimes it may happen that we try to move something, but the object is not moving. The best example is that try to push a wall, very hard wall of your home or office. Try to push it. So if that wall is not moving, or if the wall is not at all getting displaced, we can say that zero work has been done. Work done is zero. How we are getting that work done is zero? Because we cannot see any sort of displacement. Just by pushing a wall, can you tell me like how much distance the wall has moved? No. So we cannot calculate that displacement. Okay. So if displacement is zero, so it doesn't matter how much amount of force you are applying, the resultant of the work will be zero. Suppose you are applying 100 Newton or suppose 200 Newton to push the wall. So 100 or 200 doesn't matter if it is multiplying with zero displacement. So work done will be zero. Okay. So these are the basic categories of the work done, whether it is positive, whether it is negative, or whether it is zero. Okay. Now let us look into this positive, negative, and zero work done, like in terms of some sort of activities and practicality. Okay, so let's go through it. So we will be doing the first activity, that is positive work activity. Okay. Now in positive work, what we are having, so direction of the displacement is same as the direction of the force. Okay. So the best example in this particular case, or the best activity we can do, that we will try to move some object. Okay. So for that I will share my I will switch on my camera. I will change my camera angle as well. Give me a minute. Okay. And I will stop presenting as well. Okay. So what we can do, suppose I have this particular ball. Okay. I will take this thing. Okay. So I have this particular ball. Okay. And I have taken this marker. Now what I will do, I will just put some force in this particular ball and let's see what it will happen. So when we do this kind of thing, what happens? We are actually applied force in this direction. Okay, we are applied force in this direction. And the ball is also moving in this direction. So what happened? Just let me do it again. So when I pushed, so ball also moved in this direction. So application of force is also in this direction and the ball is also moving in the same direction. Okay, so in this kind of situation, what we can say, it is a positive work. Okay, so it can be any example like movement of a vehicle. Okay, so when we use, like this is basically a toy. So when we push this vehicle, it moves forward. Okay, so pushing, like applying the force, that force is also in this direction and the car is also moving in the same direction. Okay, so in this way we can say the application of force and the movement of that particular object or the displacement is in the same direction. So it is a positive force. Okay, so this is all about your positive force. I have given some other examples also. Okay, so this is the same example I have explained, that car is actually using the engine. That engine is actually producing some energy. Okay, and that energy is being connected to the wheel, and wheel is actually moving forward. If the vehicle has the if the gear is in forward direction, okay, so the car will move in the forward direction. Okay, so force as well as the car is actually moving in the forward direction. So here we can say it is a kind of positive work done. Positive work. Okay. The other example like this. An apple or any particular fruit falling from a tree. Now, what kind of force is being applied on this apple? Can anyone say? Okay, it is a kind of, or it is basically a gravitational force which is actually acting on this apple. So apple, it was actually hanging on the tree, and what happened? So there is a gravitational pull. So because of that gravitational pull, every object tend to fall toward the surface of the earth. Okay, if we are throwing any particular ball or any stone, it will climb up certain height, but after that particular height, it will fall down. Why? Because earth has some sort of gravitational pull. Okay, so here force is in which direction? The force is actually applied in this particular object, from the top to the bottom, and the displacement also happened in the same direction. So in this example, we can consider that this is a positive work for this particular item as well. Okay, so this is some example, and I have shown one activity as well, how we can confirm that whether the work is positive or negative. Okay, so I hope this part is clear, how positive work is actually being carried out. Okay, now activity 2, we will check the negative work activity. Okay, so for negative work activity, we have to understand what is negative work. It is just the opposite of the positive work, that is, the direction of the displacement is opposite to the direction of the force. Okay, we need to remember in the negative work activity that the direction of the displacement is opposite to the direction of force, or the other way around. If whatever force we are applying on any particular object, okay, in one direction, the object will be getting displaced in the other direction. So just now in the previous example, we have seen that we were applying some sort of force to the ball or to that particular car, vehicle, and it is moving forward. So both the things actually happened in the same direction. Now, how come this negative work will happen? So did we see any sort of activity here? Can we suggest any activity in this one? Yes, I can show you. So for that, let me switch on the camera. Okay, so I'm not just standing. I want to show how this particular activity just by mimicking the walking activity. Okay, suppose this is a small person. I'm just showing with my two finger. Okay, so if any person is actually moving, okay, with his or her legs, so he is actually moving forward, isn't it? So what is happening? The person is actually walking on any particular surface, and because of that, he is moving forward. So what is the displacement? What is the direction of the displacement in this case? He is actually moving forward. So displacement direction is in this direction. But while the person is walking, so what exactly he is doing? Through his finger, okay, he is actually pushing the surface in the backward, isn't it? In this way. Okay, with it is an alternative motion of the finger. So with each step, the person is actually pushing the surface in the backward direction. Okay, so here what exactly is happening? The person is actually applying force in the backward direction. in this direction. Okay, and he is actually moving in the forward direction. Okay, the force is basically applied in this direction and he is moving in the other direction. So in this way we can confirm that there is the existence of negative work done as well. So we are applying the force in one direction, okay, but the object is moving in the other direction. Okay, so let me show you some other examples also. Okay, so this example. Okay, suppose one car is moving. Okay, and when the car is in moving, like in the moving notion, when the car applied brake, so in which direction the application of brake will happen? In the opposite direction. Okay, so then only that car can stop. So this is one example of the negative work done. So car is actually moving forward and brakes will be applied to the wheels of that particular car in the opposite direction. Then only the car can stop. Fine. So this is one example of your negative work done. The other example that I have seen, this lady is actually moving in the left direction, but that particular lady she is actually pushing the surface, pushing the road in the right direction. From left to right, she is pushing and she is actually moving from right to left. Okay, so this is one example of your negative work done. Another example I can suggest you that the movement of the rocket. Okay, any space rocket, when any space engine is actually moving up in the atmosphere, so burning of those jet fuels, it will be causing some sort of thrust, and that thrust will be pushing downward, and because of that thrust, that rocket will be moving upward. So that rocket is actually moving upward, but force is being applied in the downward direction. So that is also a kind of negative work. Okay, so for our existence, we require this kind of work. Either there can be a scope of positive work or there can be a scope of negative work done. Okay, so this is some example or some activity related to the negative work done. Now let us move to the next activity, that is zero work done. Okay, so what is zero work done? That is displacement is zero in both the cases, whether it is a negative or positive. So displacement of the object will be zero. So whenever any sort of force is being applied to any particular object, and if that particular object is not at all moving from from its original position, then we can conclude that object is not at all moving. Okay, so in that case we can say it is zero work done. For example, let me show you the first figure. But in this particular picture, the mom and her daughter is actually carrying two books. Okay, so they are just holding the book. They are not letting that book to fall on the ground. So when they are actually holding the book is not moving, or in other words, we can say the book doesn't have any displacement. So in this kind of situation, we can say work done is zero. But generally, what is happening? In order to hold this book, we need to expend some energies as well, right? So for one book, it is fine, but try to hold 10 books at a time. You will feel tired very soon, right? So we are actually spending some of our energy to hold those books. But eventually, if we are just seeing this particular thing as scientifically, the work done is actually zero. Okay, but in more scientific way, if we can understand what is, if I'm holding 10 books, I am spending my energy, but why the work done is zero? But what is actually happening? We are actually balancing that particular thing. What is that balancing? That we are actually experiencing why when we are actually holding 10 books at a time, 10 books together, and it feels like I will be losing that books very quickly. Okay, so what is happening with the increase of the mass or increase of the weight of those books? Okay, and because of that particular mass, it is actually going in the downward direction because of that gravitational pull. Okay, so our energy, our like expenditure of energy is in order to balance that gravitational pull. So for one object, the weight is less, gravitational pull will be less. Okay, if we include two more books to that, definitely the weight will increase. So like gravitational pull will also increase. Okay, it is not exactly the gravitational pull is actually increasing, the force is actually getting increased. Okay, so but in actual scenario, if we look at this picture, we can conclude that if there is no displacement, then no work is done. Okay, similarly, if a man if he alone tries to push a vehicle, suppose the tire got punctured, okay, or anything like wrong happened to that particular car, or car broke down in the middle of the road, and that particular driver is trying to push that vehicle on his own and nobody is helping, and he is not able to move that vehicle an inch. But even though he is pushing a lot of effort in order to move that car from the road, but he is not able to shift the car because the car is heavy. Okay, he alone cannot shift that particular car or move that particular car. So if we just consider this particular scenario, we can conclude that the work done is zero. Okay, so this is another example where we can say, and most of the cases, like we can conclude that work done is zero. Okay, the best example, as I said, you can try doing that activity, try to push a very strong wall with your hands, or you can call your classmates or friends also to help you. Okay, if two of you are also trying to push a particular wall, it may happen that wall is not at all moving. Okay, so in that case, we can also say that whatever effort you are putting, it's total zero. Of course, you are putting a lot of effort, you are putting a lot of force into the wall, but there is no displacement. So finally, work is zero. But actually, in microscopic level, what happens? In the microscopic level, there is slight movement. Those are very fractional movement. If you try to move a wooden wall or something, you can experience a slight movement in the wall. But concrete wall, those structure, we cannot see it through our naked eyes. We have to use a very strong microscope to view the physical change of those concrete things. Okay, and those things we are not at all able to calculate the displacement, and because of that only we consider the displacement is zero, and finally the work done is zero. Fine. So this is how that we can conclude in some cases the work done is zero. Okay, the next topic that we will be covering is energy. So let's see what is energy. So energy of an object is its capacity for doing the work. Okay, it is basically the capacity of doing certain work is called as energy. The unit of energy is same that of work, that is joule. We can say 1 joule of energy is required to do 1 joule of work, or 1000 joule is equal to 1 kilojoule. Okay, so there are different forms of energy we can see or we can experience. Heat energy. So the sun is the best source of heat energy. While boiling the water, steam is coming up, that is heat energy. While burning any fire wood or any particular item petroleum thing, petrol, diesel, then compressed natural gases, LPG, the heat is actually getting produced. So all those things are your heat energy. Light energy is there. From sun we are getting the light, from stars we are getting the light. Okay, then if we are illuminating anything, suppose torch, then what you can say, candles, those are providing you the light energy. Then electric energy. So electric energy we can get from the power sources. Okay, so because of this electric energy, the most of the appliances are actually we are actually enjoying, or we are actually using most of our electrical appliances in our home. Then chemical energy we have, mechanical energy we have. So when we talk about mechanical energy, so there are basically two different categories, or we can say mechanical energy consists of two things, that is potential energy plus kinetic energy. So those things we'll be getting into details in our next slides. So when we talk about this energy, heat energy, light energy, and there is a concept of energy transformation. Okay, so because of this energy transformation, we are enjoying a lot of things in our day-to-day life. Okay, for example, I am giving this lecture. Okay, so when I am speaking, it is one form of energy, sound energy. Okay, so when I am speaking, this sound energy is actually getting like inside my laptop or my like mobile phone in the form of electrical energy. This electrical energy is actually getting like transformed via internet, okay, to the recipient, okay, and finally your microphone, sorry, your speaker of your phone or the laptops are actually getting like is actually converting that electric energy into the sound energy. So just by speaking one particular word in a fraction of second, lot of like transformation of energy has taken place. Okay, other examples are like we are enjoying like the lights. Okay, so if no electricity is there, so it is complete blackout. So when electricity is there, so what is happening, we are getting the electric supply, and definitely we are enjoying those lights. Okay, so those are also one type of conversion of the energy. And how exactly we are getting the electric energy, because electric energy source, we don't have any proper source for the electric energy. Generation of electric energy is a big challenge, so that's why we are spending like our petroleum resources. Okay, so because of those petroleum resources, we can convert the electric energy. So we have developed machineries, powerhouses. So there may be nuclear reactor, there may be steam engine, which are actually converting some sort of resources. Okay, and they are converting like with those resources, they are actually moving their like piston of the engine. So when those piston of the engine are moving, so it is producing some sort of mechanical energy. Now, when those mechanical energy are there, if we can utilize some magnetic concept, it can be converted into the electric energy. And through that electric energy, we are actually enjoying a lot of things in our day-to-day life. So that is why energy is one of the most important concept, and especially the electric energy. Okay, a lot of things we are totally depending on the electric energy nowadays, because without electric energy we can say we cannot even survive. Okay, and apart from that electric energy, we have other energy as well, and directly or indirectly we are using all those energy in our day-to-day life. Okay, so in the mechanical energy, as I said, we have this potential energy and kinetic energy together. So let's try to understand about this potential and kinetic energy. Okay, so potential energy of an object is basically energy possessed by an object due to its position or shape. Okay, so when any object is there, and because of its position or shape, that particular object is actually having some sort of potential energy. Okay, so when an object is in stationary in one particular position, then only we can say that object is actually having potential energy. Now, when the object start moving because of some external force or something, okay, so then only we can say the object is not in the potential energy, it is now in the it is showing the kinetic energy. Okay, some example of this potential energy are like if a rubber band is stretched and then released, it regain its position. So when rubber band is stretched, energy is actually transformed. So who is actually providing energy, or who is actually force, who is actually providing some sort of force to that particular rubber band? We. Okay, so through our finger we are actually providing some sort of like energy or like force to that particular rubber band. So during that time, energy is actually getting transformed and it is stored as the potential energy. Okay, so let me show you this by doing a very small activity as well. Okay, so for that I will stop sharing this, switch on my camera. Okay, so yesterday I have made this particular rubber band. Okay, so when I'm stretching, when the rubber band is there, so it is in its normal position. Now when I am stretching this rubber band, what is happening? So it is getting stretched. So till this point I am actually applying force to stretch this one. So there is a elastic kind of property that rubber band is actually having, and I am pulling this rubber band, stretching this rubber band. In this, till this position, there is no movement at all. And in this point, okay, or in this object, there is a potential energy. Okay, so there is an energy stored in this object. So if I am releasing this one, so immediately it came into its original position. Okay, so when I was pulling this one, I have applied some force and it converted into energy, and it is stored in the form of potential energy. So the basic phenomena behind the potential energy is that the energy is actually in stored form. Okay, so when I'm like releasing this one, so quickly it will come into its original position. Okay, so this is how we can understand the concept of potential energy. So there are some other examples as well we can see. Okay, we might have played with any kind of toy which may work with some sort of key. So when we wind those key of the toy car, okay, and place it on the ground, it moves. So what is happening there? When we wind the key of the car, we have applied some sort of energy in that particular key, isn't it? So that energy is actually transformed to the spring, transferred to the spring inside that car, okay, and it is stored as the potential energy. Once we release the car, or once we release that particular key of that car, immediately it start moving, because the spring, it is stored, the energy is stored in the form of potential energy. Now immediately when we like remove our finger, like further if we are not applying any force, okay, immediately that coil will like it start recoiling. That particular spring, it start recoiling, and that potential energy will release. And because of that release of the potential energy, because of the property that spring will come back to its original shape, so potential energy is released, the stored potential energy is released, and that's why the car is actually moving. So because of this particular principle, the potential energy, the spring can hold potential energy till certain point, and if we are releasing that pressure, immediately spring will come back, that potential energy will release. So because of those kind of concept, the like this kind of toy cars has been built. Okay, similarly I can show you one more picture, that is a girl is holding a ball, okay, and the ball is having some potential energy. Now how can we say that the ball is having some potential energy? What prediction we can do? If the girl is releasing that ball, if the girl is like just releasing her two hands, what will happen? The ball will fall down. Why? Now the ball is having potential energy. How the potential energy is there? Because there is a gravitational pull to that particular ball, that is one force is actually pulling that ball downward, okay, in the downward direction, and the girl is actually trying to overcome that like gravitational pull. So that's why she can hold that particular ball. Now if she's releasing that particular ball, so it will try to come in this like in its original state. So it will fall down, it will go down. Okay, so in that case we can say the potential energy is getting converted. Okay, so from this point, so if we have understood the concept of potential energy, from this point we can understand the concept of kinetic energy as well. So in the kinetic energy, what is there? The kinetic energy of an object is the energy possessed by an object due to its motion. So when the object is actually start moving, so that because of that movement, it is actually showing the kinetic energy. So all moving object possesses kinetic energy. Okay, and the kinetic energy of the object depend upon its speed. So the speed of the object, okay, the speed the object is actually having, the more kinetic energy or the more amount of kinetic energy is being shown. Suppose a car is moving with 50 kilometer speed, 50 kilometer per hour. Okay, so it is having some amount of kinetic energy. Fine. If the car is moving at 100 kilometer per hour, so the speed is double. So in that case, it is showing or it is showcasting a high amount of kinetic energy. Okay, so the kinetic energy is that the potential energy is actually transforming into the kinetic energy. The potential energy till the point we have stored in certain like specific position. Okay, once it is start moving, it is the kinetic energy. Okay, so this is about the potential energy and kinetic energy. So we can do some activity like yesterday I have like shown the same activity. I can show you and I can make you understand about the potential energy. Okay. Okay. Yesterday also I have shown this activity with a glass. The same activity we will do once again. Okay. So I am keeping this particular cardboard or a paper and I'm keeping this 2 coin. Okay, so this coin is having some mass, the coin is having some weight. Okay, and because of this weight it is witnessing some gravitational pull. So if I'm releasing this coin, it will fall down, right? Till the point I'm holding this one, it is there. If I'm releasing this coin, it will fall down. Okay, so once I am placing this coin over the cardboard, okay, so the coins are actually having potential energy till this point. Okay, so when immediately if I'm removing this card by flipping this cardboard, okay, I have to give some more amount of force. So when immediately I am flicking this particular cardboard, what is happening? The coin is actually going downward. Why this is happening? It was having the potential energy, and the potential energy is actually getting stored in this coin as well as in the cardboard. Okay, but if I am removing this cardboard, I am removing that barrier, right? There is nothing to hold. There is no force actually applied which can hold these 2 coins. So if it is empty, if it is vacuum, so definitely it will go down. Okay, so from the potential energy is actually getting converted into the kinetic energy and it is in movement. So this is how we can understand the concept of potential energy and the kinetic energy. I hope with this activity you got some idea regarding what is work, what is energy. So that's all in today's class. In case you have any doubt, you can like go through this particular video once again. Like these videos will be there in the Facebook as well, and later on you can also like contact me in case of any issue. So thank you for today's session.
Thank you, Mr. Rupesh.
Yes.
Yeah, thank you, Mr. Rupesh, for the session, and hopefully the students will be joining us soon for the next session.
Yeah,
Yeah.
I'm hoping so.
Yeah, sure. Actually, I think there's some problem with my mic. I think my voice is not coming clearly. But yeah, let's join again next time. And thank you so much for all the students joining us on video. And yeah, bye bye. Take care, everyone. And thank you so much, Mr. Rupesh.
Yes,
Bye-bye.
take care.
Thank you.
Yeah, sure. Thank you.
Thank
Thank you.